This is section 25, a two-way ANOVA, and based on making sense of statistics text. When we talk about a two-way ANOVA, it's also known as a two-factor ANOVA. Now, remember from the previous section, from section 24, and we talked about a one-way ANOVA. And an ANOVA is an analysis of variance. Now, a two-way ANOVA, or a two-factor ANOVA, is basically saying that your participants are classified in two ways. So they can be classified in two ways. So we might consider that from a variable standpoint. So let's look at example 1 in your text. It says a random sample of welfare recipients was assigned to a new job training program. Another random sample was assigned to a conventional job training program. Now, if you look at this, this is job training. Is one of the ways in which the participants were classified. So I think classification was a new job training or a conventional job training. Now also the participants were classified according to whether or not they had a high school diploma. So when we were classifying people with whether they had a high school diploma or not, you would say has a high school diploma, does not have a high school diploma, or as you can see below, high school diploma, no high school diploma. Now at the end of the training, all of the participants in each group found employment. They were employed in the private sector. And so their mean hourly wages are now shown in the table below. So when we are looking at this table, if you see that we have a high school diploma to your left, we have a no high school diploma on the column. Now on our rows we have conventional and new. So that would be the conventional job training program and the new job training program. Now let's look at the first column. So our first column of means. Now one thing also to remember is this is income. And income in large populations is usually skewed, making the mean an inappropriate average. And we covered that in section 9. But for these groups, let's just assume it is not skewed. Also note that the row means and the column means were obtained by adding and dividing by 2. This is appropriate only if the number of participants in all cells is equal. Now, so what we're doing is we're going to go under a lot of assumptions to see what we're talking about. Now, when we are looking at our column of means, so we look down here at the column and we see under the conventional column, we see that a person with a high school diploma had a mean of $8.88 an hour. A person with no high school diploma had made $4.56 an hour, and so the conventional column mean was $6.72. Now let's look at the new job training program. Now if you look, we see high school diploma had a mean of $8.75. The no high school diploma had a mean of $8.80, and the mean of the new program was $8.78. So when we look at the column means, which is $6.72 for the conventional program and $8.78 for the new training program, these suggest that overall the new program is superior to the one that is the conventional. And so in other words, what it is saying is that if we just ignore whether the participants have a high school diploma. The new program seems to actually work better than the conventional one. Now, the difference, so if we took $8.78 and we subtracted $6.72, we have $2.06. Now, this difference suggests that there is something called a main effect. That $2, the difference, the $2.06, suggests that there is what we call a main effect. Now, the main effect is the result of where we're comparing one of the ways in which the participants are classified while we're temporarily ignoring the other way in which they were classified. So now remember, we were looking at the types of program, which was one of the ways in which the participants were classified. And what we were doing also is we're temporarily ignoring whether they have a high school diploma or not. Now, sometimes it's very difficult to grasp the concept of the main effect. But, now we can look just at, so let's break this down and let's look at it a little bit differently. So here again, this way you can see the chart. The mean of $6.72 is for all of those persons who had the conventional program, regardless of whether they have a high school diploma or not. So it's just based, here again, based just strictly on the type of program. Here again, the mean of $8.78 is for all of those who had the program, regardless of whether they have a high school diploma or not. So there again, not looking at high school diploma right now. We're only looking at the type of the program. So, the only thing that we are doing, we are only looking at the effect of the program. And when we only examine the effect of only one of the ways in which the participants are classified, we are examining a main effect. So now let's look at the row means. So here are the row means. So this is where we're talking about the diploma. Do you have a high school diploma or you don't have a high school diploma? So let's look at the means for these. So we look at the mean of $8.82. Now that mean is for all of those people who have a high school diploma, and then the other mean of $6.68 is for all of those who have no high school diploma. Now, if we're just looking at the numbers for the means of those, whether they have a high school diploma or don't have a high school diploma, what we are saying is now that it says, it suggests, so the numbers suggest those with a diploma, those who have a high school diploma on average, have higher earnings than those who do not. Now, this also is a main effect. Now, remember, main effect is temporarily ignoring one of the characteristics. So we are temporarily ignoring the type of the training program. In other words, regardless of the type of program, those with a high school diploma earn more. Now, up to this point, what we would see is those of us, if we're studying welfare, we see now this is a whole different ballgame that we're now going to look at. The new program seems to be, when we look at all of it, seems to be superior to the conventional program in terms of hourly wages, and those with a high school diploma seem to have higher hourly wages. Okay, now what we're saying is, if you see, we say seems to and seems to have and seems to be, we're using this because only random samples have been studied, and so we really don't know whether the differences are statistically significant in light of sampling error or anything. All we really know is that the findings seem to be what we are talking about. Okay. Now, here again, let's look at this. Those with a high school diploma seem to earn about the same amount regardless of the program. Now, this is a third interesting finding. So we've already talked about two, and now this is a third interesting finding, that those with a high school diploma seem to earn about the same regardless of the program. So it doesn't matter which program they used, and the statement is based on the means for those who have a high school diploma. All right, and that's it. Now, let's look at those without a high school diploma. So now when we look at it, for those without a high school diploma, those people seem to benefit more from the new program than from the conventional program. And this is based completely on the means for those without a high school diploma. Now, so you can see, if you look at it from the conventional and the new program, you clearly see there's a relatively large monetary difference. Well, whether it's statistically significant, we don't know. But what we do see is, and I say this a lot, would you like making the $8.80 more than the $4.56? When we think about it from a monetary standpoint, from even our own perspective, yeah, we want to be in the new program, right? Especially if we don't have a high school diploma, because look at what it shows. Now, let's look at it as a researcher, because we just talked about it, from a perspective of, would you be interested? How would you feel? Now, let's say you're the researcher who did this study, and so you are now an expert on the training programs for those on welfare, and an administrator calls you for advice. She asks you, hey, which program should we use? The conventional one or the new one? And of course, what you can say is there is a main effect for programs that suggest that overall the new program is better in terms of wages. So overall the new program is better in terms of wages. However, if that is all you tell the administrator, your answer would really be incomplete. So the most complete answer would be this. For those with a diploma, the two programs are about equal in effectiveness. Now, those with a high school diploma, other things being equal, it is not important which program is used with welfare recipients who have a diploma. So if you have a high school diploma, we can use either program. Okay? Doesn't matter. All right, but we're not through. We still have another part. Okay? For those without a diploma, the new program is superior to the conventional. And here we go. We say it, other things being equal. So all other things being equal, those who do not have a diploma should be assigned to the new programs. And what this does is because you really cannot give a complete discussion about one main effect without discussing the other main effect. And especially because we cannot do this, we have to talk about the two ways in which the participants are classified. And so we have to say there is an interaction between the two variables. So we have to say there is an interaction between the two variables, and the interaction is between how well the type of program and whether the participants have a diploma. And so how well the two programs works really depends upon whether you have a diploma, a high school diploma or not. Now, one of the ways that we can look at whether there is an interaction. And this is an easy way where we can spot an interaction when there are two rows of means. And what we do is we would subtract each mean in the second row from the mean in the first row. And so you see we have subtracted them, and if the two differences are the same, there is no interaction. So now let's look at this data. We've subtracted $4.56 from $8.88, and we have $4.32. We've subtracted $8.80 from $8.75, and we have negative 5 cents. So since $4.32 is not the same as the negative 5 cents, the data suggests that there is an interaction. So now they're not the same. The data suggests there is an interaction. All right. So now let's look at this example in which there are two main effects, but there is no interaction. So a random sample here, again a random sample from a population of those suffering from chronic illness was administered a new drug, and another random sample from the same population was administered a standard drug. So participants were classified whether they were male and female. So now we have two different drugs, the standard and the new, and we have gender, so we have male and female. At the end of the study, improvement was measured on a scale from 0, no improvement, to 10 for complete recovery. Now let's look at our column means in example 2. Our column means, we look down, mean of 6 and a mean of 6. All right. So and our row means a mean of 6 and a mean of 6. So let's look though first at our column means. So our column means are the same. So if we temporarily ignore whether the participants are male or female, we're only looking at whether they are on the new drug or the standard drug. There is no difference. And to say this, we would basically conclude that the two drugs are equally effective. And to state it in a statistical standpoint, we would say there is no main effect for the drugs. Now the two row means are also the same. So if we temporarily ignore which drug, whether the new drug or the standard drug was taken, and we look solely at the gender, male or female, we can basically conclude that males and females improve to the same extent. And so here again, to say it in statistical terms, we would say there is no main effect for gender. Okay, everybody see that? So here again, let's look at this. These two numbers are the same, right? The two drugs are equally effective. There is no main effect for the drugs. Here again, data suggest there is an interaction, right, on this one. Now the interesting finding in this example is the interaction. The standard drug works better for females and the new drug works better for males. So now here we did the subtraction. Remember, we subtracted the column, the numbers in the columns. So we have the male had a mean of 5 and a female had a mean of 7, and we subtract those. We have a negative 2 if we have, and in the next column we have a mean of 7 with a mean of 5 for the females, and we subtract it, we have a 2. Now these are not the same. Let me say, just one is a negative 2. One is a negative 2 and one is a 2, a positive 2. Now if we were talking about it from a timeline perspective, these are from a number line, these are two entirely different numbers. So remember when I complain about you using a minus sign, what I'm talking about is these are not the same numbers. So the data suggest that there is an interaction. So subtracting, we were able to identify an interaction, for example, for the example 2. Now, let's look at this next example. So we have random samples of high and low achievers who are assigned to one of two types of reinforcement during the math lessons, and so achievement on a math test at the end of the experiment was the outcome variable. Now we have the mean scores on the test are. Now, in example 3, in this example, there seems to be a main effect for type of reinforcement. The type of reinforcement, either type A or type B. And the reason that we're saying that is, if we look at type A, we have a mean of 45, and if we look at type B, we have a mean of 25, and so it seems, to be a main effect for reinforcement. So while ignoring our achievement levels temporarily, type A seems to be more effective than type B. But there also seems to be a main effect for achievement level, as indicated by the difference in the row means. And if you look at the row means, we have 40 and 30. Now, so ignoring the type of reinforcement, high achievers score higher on the test than the low achievers. There is no interaction as indicated by the differences, which they were shown below. So here again, there is no interaction. We have subtracted, and we have found that the numbers are both the same, and so there is no interaction. So what does it mean when we're saying there's a lack of interaction in this one? Well, right now it talks. What we're seeing is it indicates that regardless of the type of the reinforcement, higher achievers are the same number of points higher than low achievers. So regardless of whether the students are high or low achievers, type A reinforcement is actually better. So now let's review this very quickly. Now let's review. A two-way ANOVA examines two main effects and one interaction. The null hypothesis should be tested because random samples are used. For each of the main effects and for the interaction, the null hypothesis states there is no true difference. No true difference. That the observed differences were created by random sampling error. A two-way ANOVA will therefore test the two main effects and the interaction for significance. And this is done by conducting 3 F-tests, one for each of the 3 null hypotheses. We've already covered F-test, and determine the probability associated with each. Typically, if a probability is 0.05 or less, the null hypothesis is rejected. See, we're building on what we've learned previously, and the main effect on interaction being tested is declared statistically significant. So let's look at example 4. The results of a two-way ANOVA are usually organized in a table. So while sometimes the tables, the information in the tables vary, the most important points are shown below. Now, it is common to include degrees of freedom, sum of squares and mean squares in an ANOVA table, but as mentioned in section 24, for the typical consumer of research, these statistics are of little interest to most consumers. But let's look at this table. The probabilities shown in this particular table indicate whether there is significance. So if we look at the main effects, so we have the achievement level and the type of reinforcement. So are both statistically significant because the values of P, as you can see that are circled in red, are both less than 0.05, the most commonly used level for rejecting the null hypothesis. Now, if you look at the interaction, that is not significant because P is actually greater than 0.05, and the null hypothesis regarding this interaction should not be rejected. So the 3 null hypotheses have been tested with a single two-way ANOVA. 2 of them have been rejected. So this concludes section 25, the two-way ANOVA. You can go back and listen to this again. And the next section is section 26, chi-square.